In this video, we're going to be looking at the character data types, the data types that you use to store text. And things are actually pretty simple here. The three main types that I'll be discussing are char, varchar, and text. For both the char and varchar data types, you also specify in brackets the maximum length of text that can be stored in that type. So if you were to write varchar 50 with 50 in brackets, what that means is that you can store up to 50 characters in that column and no more. If you tried to store some text that had 51 characters in it, you would get an error. So the n that you see in brackets after char and varchar there specifies the maximum length of the string that you can store. Char is not very commonly used anymore, and what char does is if you insert a string that's less than n, it will pad that string with spaces. You can kind of consider it more of a legacy data type. It's pretty rare that you'll want to use it these days. Varchar, on the other hand, is very common. Varchar will store exactly what you ask it to. So if you have a varchar with a maximum length of 50, if you store in that column a string of length 3, then that's all that will be stored in that column, and the var here is short for variable length. The third type is called text, which is suitable for storing near unlimited length text. So if you're storing, for example, a document, text might be the appropriate data type for you. It's not part of the SQL standard, but you'll find something analogous in most common databases. From the perspective of Postgres, there's actually not really any performance difference from using text or varchar. And in fact, in Postgres, varchar is actually implemented just as the text type with a check constraint on the length. Something that's quite important to talk about as well when you're discussing character types is how the locale and character set is managed, which is important for internationalization. How that's handled often depends on the particular database vendor. Different databases handle this differently. But basically, for Postgres, when you installed it, it picked up your locale and character set, and you can see what that's set to by running this command show all. If you run that and then scroll all the way down, lc_collate and lc_ctype. That tells you what the collation and character set is currently set to. And that's of type UTF-8, which you can verify by also typing show server encoding. And so that's good. What that's telling us is that we're storing character data in UTF-8, which is often what you want all the time as compared to something like ASCII, which will give you problems down the road when you're dealing with internationalization. Let's have a look at some common text functions and operators. And the best reference page for that is the documentation. So you can go to the documentation, search for string functions and operators, and this will bring up a lot of the common functions that you'll be using. And as it mentions here in the documentation as well, strings is essentially just another way to refer to character varying, which is varchars, and text data types. And we can have a look at common operators and functions that are available for us to use. We've already done some work so far with string concatenation. So in the past, if we wanted to concatenate two strings, we use that double pipe characters. So we could say select A, let's say we'll concatenate that with B, and we could just run that, and it's joined those two strings together. One thing to note about that though, is if you then concatenate that with null, the entire expression evaluates to null. And you may actually find that you run up against this a few times. Let's look at an example with the customer table. And what we want to do is for every customer, we want to print first name, has email, and then put their email address. So let's write some SQL to do that. And we'll run that. And that looks like it did what we wanted, but it turns out there are some customers that have a null email address. Let's look at what got printed for those. What was printed out for them was simply null, which is a little bit less than ideal. How could we have handled this better? We could use the function concat, and the description says that this function concatenates the text representation of all the arguments, and null arguments are ignored. So let's give that a go. Let's use concat. We'll say first name, we'll concatenate that with has email, and then we'll concatenate that with the email. And now let's just run that for all customers first. Let's see what it prints out. That's exactly as it was before. Now let's look at those customers that had a null email address and let's see what gets printed out. That's better. It's not necessarily ideal, but it's better than just printing out null. When you're performing text concatenation, your arguments can also actually have a data type that's different from text. And what will happen behind the scenes is there'll be some of those data types being converted or coerced into a text data type. Let me give you an example to make this a little bit more concrete. We'll continue working with the customer table, and what we'll say is that for every customer, we want to print out the date that their account was created on. And if we jump on over to the customer table, we can see that there's a column called create date, and that's of type date. So we'll clean this up, and we'll say first name was created on, and we'll put in the create date here. And that worked fine. Create date is actually of type date, but it was automatically cast or coerced into a text type here. And that's true of many other types as well. So you could also use numbers, you could also use Boolean expressions. And if you use them in an operation or an expression that also involves other character types, then they'll be converted to text, if that's possible. You can also use a function called coalesce if you wanted to substitute in a default value for when something is null. So let's just go back a little bit. We'll undo a few steps here, and let's return back all the way to that original expression we had. Here we are. We can use the coalesce function here to print unknown when the email is null. Let's run that. So for those customers where there is an email, that worked fine. And when the email is null, then we now print unknown. The way the coalesce function works is it will return the first expression that's not null. So just going from left to right in the arguments, coalesce says, is the email null? If it's not null, then it just returns the email address. If it is null, then it moves on to the next argument, and it will return that if it's not null. The string literal unknown is obviously not null, so that's what will get returned. And so the coalesce function is a handy function that you can just use if you want to substitute in a default value for when something is null. A common function that you may find yourself using quite often as well is trim. What often happens is, if you're accepting input from a user, say you've got a web application and you've got a field where the user can type in their name or email address or something like that. Sometimes you'll find users will put spaces before or after their text input. Sometimes they'll just put in spaces and submit a form. Sometimes they'll put in nothing in a field and submit a form. And the net result of that will be that if you have a column in a table that's storing that input, sometimes the data in that column will be all spaces. Sometimes it will be space padded. Sometimes it will be empty, and then sometimes it will be null. And so you need to be prepared to handle all of those different scenarios and clean up the user data that's been provided. So the first function that's quite helpful for that is called trim. And with trim, you can eliminate trailing and leading spaces from any text. Let's say, for example, that you pass in the text space, 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 Neil, space, space, space. If you pass that to trim, it will clean up that text. So the output is trimmed of all the spaces. Compare that without trim. And you can see that those spaces are still there in the output. What you want to do often then is combine that with length function. So you say length, trim, and then you pass in your text. So I'll pass in Neil. And we can run that, and we can see that the length it gives us is 4. Because there's actually only 4 characters as part of the input, and the rest is spaces, which trim eliminates. This is really helpful. You can imagine, for example, if the user just put in spaces in an input field, let's get rid of Neil there, the result here is 0. We can use that then to filter out rows where people didn't input any valid data. Let's look at an example looking at the address table. And if we look at the address to column, we can see that this is a column where sometimes null has been input, and sometimes it looks like there's been nothing or maybe some spaces. So if we wanted to return the columns that actually have valid input text in address to, what we could say is where length trim address to is greater than 0 and address to is not null. And I'll push that onto the next line. And running that, there's no results. So we didn't actually ever get any valid inputs for address to. A lot of the other string functions that are quite common we've already used throughout this course. So we've used lower in previous exercises. And if we scroll down a little bit further, let's look at some of these other functions. We've used left a few times now to obtain the first few characters of some text. We've used the length function a large number of times to get the number of characters in a string. And we even used a init cap right back in the beginning to properly capitalize customer names. One final thing I'll point out is that if you're working with any functions like substring that take positions as their arguments, so we can see that there's a substring function here, and you pass it the starting index and the number of characters that you want it to return. SQL is not 0 indexed, like many other programming languages you might have used, it's 1 indexed. So the position of the first character in a string is 1. Spend a little bit of time just again briefly familiarizing yourself with the different string functions that are available. There's quite a lot. And when you're ready, head over to the exercises to test out your understanding.